So in this experiment we need three variables, that is the Vin, that is the voltage input, resistance and capacitance. For the first experiments we will be keeping the voltage input as 7 volt and resistance as 3 kilo ohm. So for first we have to keep voltage is equals to 7 volt. So coming to the setup, we will take a multimeter and then the pin points, the positive part of the multimeter will be attached here. Okay, and there should be a reference voltage so that we will ground it here. Okay, now in the multimeter, since we are measuring the voltage, we will shift it towards the voltage sign, that is the white part on the left side. Since it is 7 volts, so we will keeping it in the range of 20. Now coming to the setup, we will try to bring on some pressure on the 2 pin points. Now going on the multimeter, we will see that the voltage is near about 7.
We can change it from here.
Here. We can change it from here by switching the knob, or turning the knob or rotating the knob. Okay, so the voltage is nearly 7. So we can just change. We'll remove it from here. It's done. Now coming to the resistance part, that we will be keeping 3 kilo ohm. For this you can just switch off the setup because the resistance will be there no matter what. So for that, these 2 points will be taken. The black one in this point, and we can see here that there is a variable resistance 5 kilo ohm. The red point will be coming here.
Okay, we have to open this.
We can open this. We also cannot open this.
Because
it depends on this.
Capacitor resistance will come here.
Okay, for your knowledge, okay, I am removing it as well. That's okay. Now coming to the multimeter, since we are measuring the resistance, we will coming to the resistance part and keep it around 20k or 2k. We will just check out whether we are getting the value or desired values or not. So we will apply some pressure over here, and since we can see that no value is coming, that means that we have to change it from 2k to 20k. Changed it, and now we can see that the value is near about 4. And in the table itself, in the second table, we can see that the V in is 7 and C is 0.01 millifarad. Now before we go to any further steps, let's come to a small part of here. Got. So as I was doing that, there are 2 capacitance, 0.02 millifarad, and if we focus here very minutely, this is 0.01 microfarad. So currently it is connected in 0.01 microfarad, just like that in the table. And now we would need a DSO. With the DSO, we will connect a probe, which will be connected with the red part will be connected with that of TP4. Here it is written TP4, and there would be a reference voltage ground. So every setup is done. We have fixed the range roundabout around 4. So we will look for this value, 4 volt, 4 kilo ohm. But first we have seen here that the value of capacitance is 0.01 microfarad, but in the setup is 0.02 microfarad. So let's change it for getting a clear idea of what we are going to apply. So just like that, we will attach it in 0.01. It's around the value of 4. The system is off, so let's on this system. We have on it. And also this will be also connected. The capacitance will also be connected. Now over the DSO we can see there is some value. So what we have to do, we will go to auto. The value, the blue button auto under run and stop. When it will be done auto, we can see here the value of the frequency, that is 8.21 kilohertz. This will be our theoretical value, which was around 8.29 for 4 kilohertz and 0.01 microfarad. This will be the theoretical observed value. There will be this formula, F equals to 0.25 RC, the value from where we can find out the theoretical value, which will be near about same or in the range. So that's for the resistance part, when we are keeping the voltage constant and capacitance constant just for once. And let's just come in these two as well for C2. So of the system once and for all, and let's connect in 0.02 microfarad. It's connected, everything is connected. So we'll on the system once again. You can see here let's go once more auto, because right about it will take some time to adjust, but let's just press on auto once and for all. And this is the value for 0.02 microfarad. We can see that the value is 0. And we can see the value is 4.90 kilohertz. In this DSO, we can see the value of the frequency is 3.67 kilohertz, which is in roundabout same. So we got the observed frequency. There is the same formula, 0.25 by RC. We can get the theoretical value of the frequency. By that logic, we can take two capacitance value. We can get the values. The two tables are done.
So as you can see in the first table, we are making V in constant and R constant. We are varying capacitor value, and we have to measure the output voltage, and we have to get the theoretical value by this formula. In the second table, we will make the same. We will make V in constant and capacitor value constant, and we will vary the resistance with respect to the resistance. We have to calculate the P out, F out, and similarly by this formula we can get the theoretical value of this.
So recording started. So for the last experiment, that is, we have to vary the voltage input, keeping the capacitance value and the resistance value as constant, as well as the VCC, that will be always constant, and that is 9. There will be this formula 2 VCC minus V in by VCC into R into C. So after this formula, we will be varying the V in, but for first we have to keep the parameters constant, that is capacitance, resistance. So coming on the setup, we have fixed the capacitance as 0.01 microfarad, and coming to the resistance, we have also fixed the value will be around 5. Yes, the value will be around 5 for the resistance.
So
we have fixed
take
that thing.
caution before taking the reading of the resistor. Make sure this string is open from here.
Okay. For the next part is that we have to vary the voltage. So we will be putting the pins over here in the of the multimeter, changing the multimeter value from resistance to voltage, and we will be keeping the value of 20. At 20, and now we will be changing the value. Like now we can see that the value is given at 7.5, and we can see it in the multimeter as well. So yeah, that's done. Now what we can do, that we can be changing the value by switching over the knob, and we can see over the multimeter the value has changed. We are changing it here, the value is being changing. So by that logic, we can get up to 5 readings over here, starting from 7 to 8.5, and depending on the values we want. From there, let's just take one more reading. We have done for 7.5. We will go for, let's say, 8. So over in the multimeter, I would be turning it. We cannot be and taking the value of near about 8. It's done. After it's done, we can remove the pinpoint multimeter. Done. So last but not least, just connect the VCC along with the capacitance over your variable resistance. We can see over here in the DSO that the value of the frequency is 5.36 kilohertz. Yet if you have any other confusions, we can select on auto to check whether the values are okay or not. And over here in the values, we can see after pressing on auto, we have the values of 5.37 kilohertz, that is the theoretical value or the observed value we are getting. And for 8.5, the value is near about 5.75 kilohertz, approximately the same. We have got the frequency of the observed value. Now we can apply on the formula, and we can get the frequency of the theoretical output, which will be same equals to that.